Hi fellas, this is Chemaddcts again to the solution. Welcome back to another video tutorial. Well fellas, today we're gonna solve the third part of this question. So if you have missed the previous part, don't worry. I will put the link to the previous part at the end of this video tutorial. So stay tuned. Okay. So let's read the question. When propene reacts with hydrogen chloride, there are two possible products, a major product and a minor product. Okay, so this is the major product and this is the minor product. So draw the displayed formula for these products. Okay, they have asked us to draw the displayed formula of these products. So in here, the two possible products, let us see the two possible products. So this is propene, right? So in here there should be one CH3, here one H, and in here this is H, this is H. Okay. So in here we are reacting with propene with hydrogen chloride. So this is HCl molecule. So here there are two possibilities. Here Cl might bond here and H might bond here, or it can be other way around, that is H C, then C, this is H3C, then this is H. This can be other way around. Here H can be here and Cl can be there. Well, so these are the two possible products for this reaction. Okay, so when propene react with hydrogen chloride, there are two possible products. So why this reaction produces two possible products? Well, as you can see that this is an asymmetric alkene. So these products are formed from asymmetric alkenes. When alkenes are asymmetric, okay, this is an asymmetric. Uh, this forms from asymmetric alkene. So when it is formed from asymmetric alkene, that is this one, this molecule, from this particular molecule. So since this is formed from this asymmetric alkene molecule, so there will be two possible products. Okay, so one of them would be a major product and another one of them would be minor product. Okay, so since this alkene is asymmetric, so this will form two different products. Okay, fine. So now let us know which one should be the major product and which one should be the minor product. Okay, so let us have a look here. uh, this one is the major product and this one is the minor product. Okay, so this is the minor product and this is the major product. This one will be major product. So here let us see why. So this particular molecule is formed from this carbocation. Okay, this is one carbocation. Here chloride, what? Uh, yeah, this is chloride electrophile, nucleophile. Sorry, this formed from this molecule, this carbocation molecule. This carbocation is secondary. This carbocation is secondary carbocation. So this is secondary carbocation. Okay, and the other one, this one is formed from uh, primary carbocation. It should be here. This is plus, then yep. So this nucleophile will be added here. So in here, this is secondary carbocation and this is primary carbocation. Okay, so let us see why. In here, the carbocation, um, the carbocation atom, here in the carbocation atom, we can see that there is one alkyl group is attached over here and one hydrogen is attached. So since there is a minimum number of hydrogen is 1, so this should be secondary carbocation. And if we look at here the minimum number of hydrogen attached to this carbocation is 2, so this should be primary carbocation. Okay, so here the minimum number of hydrogen attached to this carbocation is 2, so this should be primary carbocation. And in here the minimum number of hydrogen attached to this carbocation is 1, so this should be secondary carbocation. Or in the other way round, we can say that here we have one alkyl group attached to this carbocation, so this should be secondary carbocation. And in here there is no alkyl group is attached to this carbocation, to this particular carbocation, so this should be primary carbocation. So since this particular product is formed from this what this molecule, so this should be minor product since this is formed from primary carbocation. Okay, so let us see. Mm. So let us have some more space. So in here primary carbocation, since this product, yeah, particularly this minor product, so this is the carbocation primary. Let me write it again. Okay, so this is the primary carbocation. uh, which one? This is Cl 3C H. So this is the primary carbocation and this is secondary carbocation. Okay, sorry, this should be H. This is the secondary carbocation. This would be the secondary carbocation H plus H. So in here we can see that from this carbocation we can this thing is formed. Okay, and from this particular carbocation this this thing is formed. Okay, so in here, since this molecule is formed from this primary carbocation, so this should be uh, minor product, and since this molecule is formed from this secondary carbocation, so this should be major product. Okay, so this is minor product and this is major product. So why this thing should be the minor product? That's because uh, 2 degree carbocation 2 degree carbocation are more stable than 1 degree carbocation. Okay, so since 2 degree carbocation 2 degree carbocations are or 2 degree or secondary carbocations are more stable than 1 degree carbocation, so this should be the minor product and this should be the major product. So I hope that you have understood the mechanism. Now let's get back to the question. So what would be the major product? So the molecule which has 2 degree carbocation. So at first let us draw the structure for 2 degree carbocation, then we will attach to the molecule later on. Okay, so for 2 degree carbocation the hydrogen must be added here and chlorine should be here. Okay, so this is the major product, and for the minor product this should be 1 degree carbocations. Okay, so the minor product is formed from 1 degree or primary carbocation. So at first let us draw the structure for uh, 1 degree carbocation. Okay, so major product, here we have learned one thing, that major product is formed from secondary or 2 degree carbocation, and the minor product is formed from 1 degree or primary carbocation. Okay, so this is how it goes. So now uh, let us answer this question. Give the mechanism for the reaction of propene with hydrogen chloride, which forms major product. So the major product should be like this. Here we have propene molecule. Okay, and here we have HCl molecule. So the HCl molecule would form this polar. Since HCl molecule is polar molecule, so this will bond. This bond will be break heterolytically. This will break heterolytically, and this electron will come here. Okay. So as we can see that since the first species that attack this bond is attack this particular bond is an electrophile, so we have named it electrophilic addition. Since the first species is electrophile that attack first is electrophile, the first attack is by the electrophile. Since the first attack is by the electrophile, so this mechanism is electrophilic addition. Okay. So now let us draw uh, the carbocation from which we can find the major product. So this should be the secondary carbocation. So at first let us draw the structure for secondary carbocation. This is alkyl group, methyl group. This is H, C, then in here this is H. So here we have secondary carbocation. Okay. In here later on chloride nucleophile will attack here. Attack, thus forming this molecule C H3C. So this is ClH. So fellas, this is the mechanism. Okay, thus forming this mechanism. So fellas, I hope that you have understood the mechanism. The mechanism is little bit tricky. So, but still, I hope that you have understood. Okay. So, fellas, if you have any question regarding this topic or if you don't understand this mechanism, please let me know in the comment section. Okay. So I'm always there to help you out. So that's it for today, fellas. Stay awesome, stay cool. Best of luck for your exam, and as always, peace with chemistry.